Hello everyone. This video will be interesting to audio forensic analysts doing voice ID analysis who want to know how speakers ID procedure might be automated and improved in its reliability and objectivity. SIS2 software, which is a base app for STC Forensic Audio Workstation, provides unique and powerful tools for speaker comparison. Well, I got two files, both received from telephone channel. Segmentation is already done, and there's a voice of one speaker in each recording, which I need to compare. First, you might need to assess the quality of both files to make a conclusion whether they might be accepted for voice ID or should be discarded. So we go modules, signal analysis. This stage of analysis is fully automatic. So you just press calculate for telephone channel, and SIS2 can calculate the following signal characteristics: amplitude frequency characteristics, or frequency response, sound to noise ratio in a given range, in a given bandwidth. So you can narrow the bandwidth and it will be automatically recalculated. The presence of tonal noises, reverberation time, the presence of clipping, and the duration of pure speech signal. And the conclusion, if it is accepted or not. This can be saved to the project. This should be done, of course, for both files. If you have text transcript for a voice sample and investigate recording, you can use Find Matching Words tool. Go Service, Find Matching Words. This instrument finds all words that repeat in two text transcripts. It's done in a moment, and it's a valuable asset for voice print analysis. So the next stage might be automatic comparison. That is comparison of two speech audios in a fully automatic mode with STC biometric engine. The automatic identification module does one-to-one comparison using three independent methods: spectral format comparison, pitch, and GMM method. If you use all three methods, they are fused together in a final solution with different weight coefficient. The biometric engine were trained on a speech corpus containing tens of thousands of speakers, different recording sessions, and channel types. The software returns not only the average probability received on a training database, but also the minimum probability and the maximum possible probability. Plus, we got a summary which is based on the fusion. So you can save results to the project to use in an overall conclusion. Before you start using automatic comparison, you can also use a speech detector. This module automatically detects speech parts, and it shows with the marks all the portion of the signal which will be taken for automatic identification. If you want to, you can make corrections of these marks. Okay, let me hide the marks, so if you don't need them, you can hide them. The next one is performance comparison module. The performance comparison module automates voice print analysis. To start using all the benefits of this tool, we need first to extract performance tracks. Performance are the resonances of the vocal tract, which, let me say, describes the nature of the vocal sound and biometric traits of a speaker. To extract performance tracks, you can use two format extractors in SIS2. One is called LPC, another one FFT. The difference is FFT works a bit longer, but it is more precise. LPC working faster, but well, less reliable. And probably, most likely, I would say, you would like to overlay formats and sonograms, so that you can do corrections if needed of the vocal of the performance tracks. Okay, let me close the manager panel. So when the formants are extracted, you can zoom in and you can check whether they were extracted correctly, and if needed you can do editing. So the corrections can be done with the right click, edit mode, draw, and erase. So you go through the whole file and you do corrections. So it might take time, but actually it is rewarded. The same is done on the second file. Well, when the formants are corrected, we can launch our performance comparison module. The whole process can be divided in two stages. At the first stage, we search for speech sound that we will select for further comparison, and then we will compare the selected sounds. So the search can be executed in a numerous way. The first way is using the horizontal marks. So I set, well, most likely 2 marks. And then I use the position of the horizontal markers, use horizontal marks, to search all sounds, all realizations of sound, where the position of the horizontal marks marking formant number 2 and formant number 1 will be around the same position, with some threshold which you can set in percent from the position of the horizontal mark or in hertz. So when you move the marks, the position, the search criteria is also changing. You can also set the duration of a sound. So the lower the less duration is, the more sounds you will find. So and you press search. So these two formants are related to sound A, and all A sounds were found. So you can check each realization. So you can also play it back.
No.
You can also sort out by any criteria. For instance, I want to delete all fragments where the formant number 4 is missing. So then with Ctrl A, I select all fragments and add to the selected fragments. The same is done to the second file. Search, select, add. Then I can compare A-like sounds. The second option for searching, so let me delete the previously found fragments. So select all and delete. The second option is using scatter plot. So you can set the position of the formant number 1 and formant number 2 using Control button and moving the dash line. So for instance, I want to find all fragments in this area, or let it be all like sounds. Okay, let it be like this. They go here, and I press search. Let me find more stable realizations of all like sounds. Delete all fragments with missing formant number 3 and formant number 4. Add them and do the same for the second file. And again, you can compare all like sounds. One more option is, well, probably the easiest way is search all sounds. So let me delete the previous search. Okay, all sounds A, all sounds E, all sounds E were found. So you can add them and do the same for the second file. Search all sounds and add. Then we go to the compare page. For comparison, you can use different options. You can compare average position for all 8 sounds, for instance, the average position of all formants. So you can compare formant number 1, which is pretty close, the average position for 59 fragments and 49 fragments for the same. And the second one is actually 10 hertz is not a difference at all. The formant number 3 and the formant number 4. So it looks pretty much the same. You can also do this, the comparison of the average position for different sounds. Then you press compare. You can compare one sound or you can compare all sounds. Moreover, on a scatter plot, you can also see the distribution of the sounds for both speakers. You can use them as all realizations of the sounds, or you can use only root mean square area. So on this plot you can see how the scale of pronunciation, the particular sound, is similar to both speakers. So how the root mean square is overlapped for both speakers. You can also change the axis. This is the axis for formant number 1 and formant number 2, but you can change it. So you can see the distribution for different formats. This can be copied in your report. When you press compare, you can see in the first column you can see the intra-speaker variability or within speaker variability for speaker number 1 and speaker number 2, and then you see the distance, which is the inter-speaker variability or between speaker variability, and also the probability. If the sound is green, it means this is the same sound, so the realization is the same. The yellow would be uncertain, and the red would be elimination or different. And the result goes as a text, so you can save it in your report. So the next step in our ID procedure would be comparison of pitch. And the whole procedure of pitch comparison is pretty much like performance comparison. So we take two files. First we create sonograms, but for pitch comparison we draw cepstrum. So on a cepstrum you can see the pitch and the melodic pattern. And you can also compare various statistic values. Well, there are many ways how to do that, and it can be done in pretty much automated way using pitch comparison module. And again, like with performance, before you run pitch comparison you need to extract pitch. So all mistakes should be eliminated. So everything is pretty much correct. Okay, fine. Then we do pitch comparison. Well, the comparison is based on various numerous statistic values, and you can compare different types of melodic pattern: nucleus plus tail, syntagma, or you can use speech paragraph. Actually, speech paragraph is a pretty long fragment of audio file which lasts 10 seconds and more, and well, this is actually the easiest way of comparing. All you need to do, you select a fragment. So mind that it should start where the pitch starts, and the same with the ending. Then you take another one, and again add. So you have the parameters like a maximum frequency on this fragment, average, minimum, rate of pitch change, and well, actually many other parameters which will be compared. So take at least 3 fragments for a file, and then go compare. All the parameters has been compared, and you can evaluate them, and you can receive a summary on this comparison. Everything can be exported to Microsoft Word. Okay, the next one, the next module. Voice ID analysis is also using auditory comparison, linguistics analysis. This can be performed with auditory comparison module. What does this module do? An expert can estimate different parameters of voice, which can be evaluated by listening to audio file, and you can mark the voices as high-pitched, middle-pitched, a voice changing in pitch, and there's a sound examples for each feature. So you can mark the feature. You can also mark it as being important or not very important. And you go through the whole list, which is given for your reference, what can be estimated. Overall voice quality, is it a hard voice or soft voice or gentle voice or strong voice, etc., etc. Deep voice, clear voice, the loudness, intonation, tempo, articulation, distinct or indistinct, the presence of speech folds, the manner of speaking, shy manner or friendly manner, etc., etc. The filled pauses or the pauses of hesitation, and what kind of fillers you have, like sounds, like sounds, like sounds, etc., etc. So everything can be evaluated. In comparison, it gives you the summary, the number of features which has similarity or mismatch, and again you can save it. Well, that's it. As you understand the order of in which you run your analysis doesn't matter. You can start with auditory analysis and then go to automatic analysis or performance comparison, or you can start with speech analysis and then go to any other methods. It's up to you. After you finish with all different types of investigation, you go to overall conclusion, and the overall conclusion shows you the final solution, which would be based on all methods used for identification. So we have a probable identification results, probably the quality of the human assisted methods were not good enough, speech length 87, which is a bit less than recommended, but I can increase the weight of some methods. If speakers are in different emotional state, I can tick it on, and the weight of pitch dependent methods will be decreased. Now it's a positive identification because the weight of pitch in overall conclusion is will lessen. So when you finish your analysis, you can generate PDF report, which will include the results of each method. For performance comparison, there would be a table of all compared fragments, the same for pitch. That's how it is done with SIS2. Well, I hope you enjoyed the video, and the demo version of the software is available on the website, so you can download and test it. Well, we'll be glad to hear from you. Goodbye.